Hi, I'm Simone Olimpio and I'm an Italian student. I study at Riga Technical University for the first semester of the academic year 2017-2018. With this video, I would like to speak about distributed system. I will present the topics about what is distributed system, the main goals of distributed system, and some example of distributed systems. I will also present the topics studied during this course. Various definitions of distributed systems have been given in the literature, none of them satisfactory and none of them in agreement with any of the others. For our purposes, it is sufficient to give a loose characterization. A distributed system is a collection of independent computers that appears to its users as a single coherent system. This definition has several important aspects. The first one is that a distributed system consists of components that are autonomous. A second aspect is that users think they are dealing with a single system. This means that one way or the other the autonomous components need to collaborate. How to establish this collaboration lies at the heart of developing distributed systems. Note that no assumptions are made concerning the type of computers. In principle, even within a single system, they could range from high-performance mainframe computers to small nodes in sensor networks. Likewise, no assumptions are made on the way that computers are interconnected. The goals of a distributed system are connecting users and resources, transparency, openness, and scalability. The main goal of a distributed system is to make it easy for users to access remote resources and to share them with others in a controlled way. Collaborating and exchanging information can be made easier by connecting users and resources. Transparency is the concealment from the users and the application programmers of the fact that the processes and resources of a distributed system are physically distributed across multiple computers. A transparent system is perceived as a whole rather than as a collection of independent components. It is important for a distributed system to hide the location of its process and resource. A distributed system that can portray itself as a single system is said to be transparent. The various transparencies need to be considered are access, location, migration, relocation, replication, concurrency, failure, and persistence. Aiming for distributed transparency should be considered along with performance issues. An open distributed system is a system that offers services according to published standards that describe the syntax and the semantics of those services. For example, Internet is an open system as the specifications of Internet protocols are published in request for comments. Services in distributed systems are generally specified through interfaces, which are often described in interface definition language. Interface definitions written in an interface definition language specify the syntax of the services. For example, the names of the functions that are available, the types of the parameters, return values, and possible exceptions that can be raised. Semantics of interfaces are specified in an informal way by means of natural language. Benefits of open distributed systems are interoperability. Components written by different programmers can easily work together. Portability. Application can be easily ported between different distributed systems that implement the same interfaces. And extensibility. New services can be easily added and all the service can be easily re-implemented. Open distributed system must be flexible, making it easy to configure and add new components without affecting the existing components. An open distributed system must also be extensible. Scalability is one of the most important goals, which are measured along three different dimensions. First, a system can be scalable with respect to its size, which can add more users and resources to a system. Second, users and resources can be geographically apart. Third, it's possible to manage even if many administrative organizations are spanned. Scalability problems are site scalability and geographical scalability. Site scalability because as the number of users and resources increase, the system may become overloaded. Geographical scalability because as the distance between nodes increases, communication delay becomes significant. Let's name some examples of distributed systems. Here are some examples. A single client machine communicating with a server. For instance, if you know NFS, if you have used NFS, Networked File System. Single client may communicate with a single server. That's a distributed system. A BitTorrent, which BitTorrent is a peer-to-peer overlay which consists of many millions of clients communicating with each other, is again another example of a distributed system. The internet, where you have many servers and clients and routers and switches communicating with each other, is another example of a distributed system. And the web, where you have servers and clients communicating amongst and with each other, is an example of a distributed system. Ad-Hop and data centers are examples of distributed systems. What are not examples of distributed systems? Well, if you have a collection of humans, say in a party, interacting with each other, that's not a distributed system. A standalone machine not connected to the network and with only one process running on it is, again, an example of something that is not a distributed system. During this course, we use different software: Octave, Snoopy, Bash and Python. Octave is a high-level language, primarily intended for numerical computations. It provides a convenient command line interface for solving linear and nonlinear problems numerically, and for performing other numerical experiments using a language that is mostly compatible with MATLAB. It may also be used as a batch-oriented language. Octave has extensive tools for solving common numerical linear algebra problems, finding the roots of nonlinear equations, integrating ordinary functions, manipulating polynomials, and integrating ordinary differential and differential algebraic equations. It is easily extensible and customizable via user-defined functions written in Octave's own language, or using dynamically loaded modules written in C++, C, Fortran, or other language. Snoopy is a tool to design and execute hierarchical graph-based system descriptions. The tool comes along with several prefabricated graph classes, especially some kind of Petri nets and other related graphs, and facilitates a comfortable integration of further graph classes due to its generic design. To support an aspect-oriented model engineering, different graphs classes may be used simultaneously, and graphs of different classes can be converted into each other. Snoopy provides some features, which are particularly useful for larger models, or models with an higher connectivity degree. In the figure, we can see the result of the experiments we did with Snoopy. With this experiment, I tried to study as 10 bytes are exchanged from one point to the other through a cube-shaped path. To do this, I used Snoopy software. The starting point is the node A, where all the bytes are placed. After the other 6 nodes, all the bytes arrived in the same node F. A PetriNet is a collection of directed arcs connecting places and transitions. Places may hold tokens. The state of marking of a net is X a segment of token to places. Here is a simple net containing all components of a PetriNet. Arcs have capacity 1 by default. If other than 1, the capacity is marked on the arc. Places have infinite capacity by default, and transitions have no capacity and cannot store tokens at all. With the rule that arcs can only connect places to transition and vice versa, we have all we need to be using PetriNets. A transition is enabled when the number of tokens in each of its input places is at least equal to the arc weight, going from the place to the transition. An enabled transition may fire at any time. When fired, the tokens in the input places are moved to output places according to arc weights and place capacities. Born Again shell is a free Unix shell that can be used in place of the Barn shell. It's a complete implementation of the IEEE Portable Operating System Interface for Unix and Open Group Shell specifications. Bash is basically a command processor that typically runs in a test window, allowing the user to type commands that cause actions. It can read commands from a file called a script. Like a Unix shell, it supports the following: file name wildcarding, piping, here documents, command execution, variables and control structures for condition testing and iteration. We used different commands such as echo, nc, cat, ls, time. nc is the command which runs netcat, a simple Unix utility that reads and writes data across network connection using the TCP or UDP protocol. It is designed to be a reliable backhand tool that can be used directly or driven by other programs and scripts. At the same time, it's a feature-rich network debugging and exploration tool, since it can create almost any kind of connection you would need and has several interesting built-in capabilities. CAT stands for catenate. It reads data from files and outputs their contents. It's the simplest way to display the contents of a file at the command line. Cat is one of the most commonly used commands in Linux. It can be used to display text files, copy text file into a new document, append the contents of a text file to the end of another text file, combining them. CAT stands for catenate. It reads data from files and outputs their contents. It's the simplest way to display the contents of a file at the command line. CAT is one of the most commonly used commands in Linux. It can be used to display text files, copy text file into a new document, append the contents of a text file to the end of another text file, combining them. ls lists files and directories. If the path name is a file, ls displays information on the file according to the requested options. If the path name is a directory, ls displays information on the files and subdirectories therein. You may obtain information on a directory itself using the -D option. If you don't specify any options, ls displays only the file names. When ls sends output to a pipe or a file, it writes one name per line. When it sends output to the terminal, it uses the -C format. Echo is used to repeat the text typed in back to the screen and can be used to echo to a peripheral on the computer, such as COM port. Python is a general-purpose, high-level programming language. Its design philosophy emphasizes code readability, and its syntax allows programmers to express concepts in fewer lines or code than would be possible in languages such as C. Python supports multiple programming paradigms, including object-oriented, imperative, and functional procedural styles. It has a dynamic typing system, automatic memory management, and a comprehensive standard library. Like other dynamic languages, Python is often used as a scripting language, but it can also be compiled into executable programs. The simple HTTP server module that comes with Python is a simple HTTP server that provides standard GET and HEAD request handlers. An advantage with the built-in HTTP server is that you don't have to install and configure anything. The only things that you need is to have Python installed. That makes it perfect to use when you need a quick web server running and you don't want to mess with setting up Apache. You can use this to turn any directory in your system into your web server directory. We used the simple HTTP server to exchange files from server to client with the command tcpdump. It is a type of packet analyzer software utility that monitors and logs TCP/IP traffic passing between a network and the computer on which it's executed. tcpdump is an open source network utility that is freely available under the BCD license. tcpdump works on the command line interface and provides descriptions of packet content in several formats depending on the command used.